So we're doing this in English. I'm just curious how many people speak only or speak Spanish or Catalan, just to be curious, who don't speak Spanish and Catalan, who only speak English, just so we know. Quite a few, interesting. That's great. If you asked that question 10 years ago in Barcelona, there'd be nobody because there was not that much people coming in and out of the city doing research. In fact, I did all my research abroad. I worked in Canada, in England. I see some familiar faces in France, and only about 10 years ago I came back to Spain to work for Yahoo Research. And then about 5 years ago, I founded Websays with some friends, including Oscar, who is in the room. You can ask him questions after. And it's interesting because you're going to hear almost the opposite of the first talk. In the first talk, you heard, take something simple that is right there, do it well, and then you can be very successful. And they were extremely successful, and that's really exciting. We did it the opposite way. We did something really hard that is really far away. And I think we're being successful too, which means there's a huge range of things you can be involved in, from the getting it right from the business perspective to do hardcore research. And there's a lot of avenue for everybody in there. In our case, we kind of also realized, like a lot of people at the time, oh, I guess this is it. We realized that user-generated content was important. It was so important, and in fact, at some point around 2009, we had this feeling that our brains, our emotions, our thoughts were already on the internet. It's like there was the original internet was web pages that were connected, and the new thing, which we called MindNet, to give it a name, it was like minds were already connected somehow, because when people were angry, when people were hungry, when people were happy, they would tweet, they would blog, they would send a comment, right? It's almost like we were communicating with our minds to each other in real time, and that's quite amazing and quite scary at the same time. And so we were thinking, okay, that's really great. That's an amazing amount of data moving around the web, and potentially you can change politics. We've seen the internet change entire regimes in countries, right, around 2010. You can change the way medias work, and in fact, a lot of newspapers are having a lot of trouble to survive today because of this. You can change politics, you can change marketing. There's all these things you can change, but in fact, it's not so easy because this data, a lot of this data is textual data. It's people saying things. And if you study computer science and you've studied physics or mathematics or statistics, you probably never even consider using textual data. Because you know how to do Fourier transforms, you know how to do average, and you know how to do correlation analysis. We have all these techniques to deal with data. But if I give you an Excel full of sentences and I say, do something with this, what are you going to do? You say, well, we can count the letters, right? The letter A appears 325 times. Okay, that's interesting, right? What else can we do with an Excel full of comments, right? It turns out that, a lot of people have been thinking about this very hard problem for a long time, and there are things that you can do, and I'll show you some examples today, but it wasn't clear, at least 10 years ago, what were the things we could do with this data to do stuff, right? And so we took the opposite view of Review Pro. We said, okay, we don't know what we want to do, but we know it's going to be big, and we know it's going to be important, and we are good at this, so let's do stuff, and let's figure out along the way where the money is and where the killer apps are. And unfortunately, we haven't figured it out yet, so we are not being sold to Chinese companies yet for lots of millions of dollars, but it means we are still there. We have a lot of attention for many people that are looking at us and curious about what we're doing. We are, have potential for investment. We have a team of over 15 people now, which get salaries every month. So we're actually moving ahead with our research program, and we actually have products that are in the market. We have over 50 clients. Our revenue is somewhere above $500,000 a year, so it's very far from a successful company, but it actually tells you that we have real products that people are paying for every month, and they're extremely happy about them. So it's not just a research lab, it's actually a company that is putting products out there. And in fact, today, because they asked me to talk only 15, 20 minutes, I won't talk much about our products because I thought it would be more interesting to talk about technology. Go to websays.com. This is our company called Websays, right? What the web says about you. Go to websays.com. You will see lots of examples of how we use technology and what are our main products. Today, I'm not going to talk about products, but a little bit more technology because I think that's probably what you're most interested in given this particular crowd. I don't expect to make a lot of sales tonight, just to give you ideas about what we do. Okay? So what we're trying to do is our opinions are a new form of raw material. We agree on this, and it's changing the world, but how do we use this raw material? It's hard, it's very hard, and so we're trying to develop analytic tools. In fact, we're trying to exploit on 50 or 100 years of research at university to actually do things that are useful for people in real time, right? And so we need complex analytic tools. And just to give you an overview for those who haven't thought about this, why is it hard to deal with text? Because numbers, we know we can do a lot of things. So why can't we do similar things with text, right? It turns out text is very nasty with computers. Computers are not used to deal with text. They're used to deal with binary numbers or even real numbers, but that's about it. So just to give you some examples. So this is a sentence from Winnie the Pooh that says, birds can fly, but flies can't bird. That's a correct English sentence, except, of course, this is not a verb. In English, you cannot use bird as a noun and a verb, right? But you can use fly as a noun and a verb. So you can do things naturally in your head. You can parse this. You can say, OK, flies, this is actually a noun, and it's the same as this noun. Oh, it's just a plural. But bird is actually a noun over here, but this is a weird verb. It's not a verb, so your brain goes funny, and then you laugh, right? All of these operations are happening because words cannot just be taken at face value. You cannot take a hash of this word and assume that any other hash of this word will have the same meaning, right? So morphology matters. How you write things matters. Semantics matter. You know, so many words that are ambiguous, like Zara, right? One of our original clients where it turns out Zara is a very common surname in North Africa. So if you're following tweets about Zara, you're going to be following lots of tweets about women talking about their everyday life because their name happens to be Zara. And of course, all of these words are, almost every word you can think of is extremely ambiguous, right? And then you have to worry about order, right? In case of, if you have numbers, you can think of time series and then do analysis of time series. But if you have a sentence, you worry about order. So if I tell you, I, wait, for, airport, will, at, you kind of get a sense. You know kind of what's going on. Somebody's going to wait for somebody at the airport. But do I have to wait for you or you have to wait for me? That's not clear because I've destroyed the sentence, right? So order matters a lot. And even if you get the order right and the lexical semantic right and the morphology right, then semantics kicks in. And semantics is something our brain does that is actually hard to describe. I'll just give you an example. So if I say Indians eat food with chili means that you put chili in the food. And your brain automatically assumes that with chili means a modifier of the way you eat it. You eat it, we put in chili in it, right? But if I say Indians eat food with their fingers, your brain does not assume that they're actually eating their fingers, right? That wouldn't make any sense. Although in the case of chili, they are eating the chili, right? So in this case, your brain makes, OK, that cannot be right. So it makes a switch and it says, OK, maybe it's a modifier about the way they're eating it, the method by which they're eating it, right? And so your brain makes decisions like that all the time. But a computer needs to know that people don't like to eat their own fingers before it can parse that sentence, right? And so this is hard because it's not just parsing the sentence. It requires knowledge about the world. And that's why often people talk about the AI complete problem. In order to parse language, you would have to actually be as smart as a human because you need to know all the things about a human before you can parse them. So there's a lot of things that are problematic with sentences, and it goes beyond that, actually. And so it's very scary, and the first impression is, OK, we can't do anything. But it turns out language has a lot of regularity, a lot of things that you can do to actually get a first sense of what's going on. And so that's what we are exploiting. You've heard how they did text analytics for hotel reviews. I'll show you some examples later as well. We are exploiting the easiest levels. Somewhere between here and here, we're actually exploring the fact that a lot of language is actually not so hard to parse, and we can parse a big part of it and then get some knowledge out of it. We're still very far from being able to completely understand sentences, but we can do a lot of things today. And this is the kind of thing, for example, we can do. Given a sentence, we can figure out that sue is a verb and is a social verb. It involves people doing things with other people. So that's semantic information that is interesting. We know that AT&T is an organization. We know that claiming is a communication verb. And so we can do a lot of first-level analysis of words. This is a little bit like if these were numbers, you know a little bit about these numbers. You know that some of them are prime. Some of them can be divided by 3. You know some things about those words, and then you can do stuff with them, right? And you can actually do more and more. Nowadays, this full kind of parsing becomes more familiar with it. The whole sentence that you saw before becomes a graph. And you can actually see that the important thing going on is that MCA sued AT&T. And that's the important part. So you can actually count how many people sued other people, right? You can do that kind of thing now with this sentence because it's become a graph. And if you know computer science, you know data analytics, you can analyze graphs. You can put that in a relational database. And you know these are roles, and you're done. So mapping text into this kind of structures that we can use with computers is allowing us, for the first time in history, to treat text as data. And that means to treat opinions, to treat newspapers, emails, comments, as if they were data, to do some stuff. We cannot do the full AI understanding, so we cannot ask all the questions that we want to the computer, but we can do certain things more and more. Okay? So what can we do today? Well, what can computers do with language today? And that's the things that we've been working on Websays at different levels. Computers can answer some types of specific questions. You've seen this if you go to Siri and you ask him, when was Bob Dylan born? They will tell you, right? This was the thing impossible 10 years ago, and now it's trivial, right? So computers can answer some types of very specific questions, and they're doing this now in a fairly regular way. They can also tag parts of sentences. So when you saw in Review Pro, for example, when they were actually taking a mention and saying this is positive about this particular topic, they're tagging a little part of a sentence, right? So we call this tagging. And we can also classify entire sentences and entire documents in real time, which allows us to say, you know, a message is positive with respect to a brand, or a particular message is for or against a politician or a brand or a person, etc. Right? So what kind of technology? Well, you need a lot of technology, and those who are interested, you do things like you get the data first from social feeds, from review scrollers, focus scrollers, etc. Then you do some crawling, you do some parsing, you do some filtering, you do some data analysis, you do some semantic analysis, social graph analysis, indicators, and eventually you end up with a data set which has the original data, which is your tweet, but it's extremely enriched. It has all these markers all over the place. And these markers allow you to start querying the database as if it was data, real data, not just text, right? So now you can start writing programs in SQL, in whatever flavor you like, in Pig or whatever you like, which are accessing data. And what's nice is that often the guys doing this know about text, and the guys doing this know about data. And they actually don't have to work together all the time. And they have to know what they're doing, but these are two different words. It's like pre-processing step to everything else that you do, right? In our case, in Websays, if you go to our website and you look at our products, you'll see that our main two products, what we do is we collect opinions about politicians, brands, cities, products in general. We do all of this work to end up with a lot of analytics about what people are saying. And depending on the application, you will care about one type of analytics or another. I'll just show you a couple of examples in a minute, right? And we show you this through a dashboard, which is basically a sort of software as a service. You subscribe, you tell the computer, okay, I want to track this product, or I want to track this politician. And then we go, we get all the data, we do all the analytics, and we show you in the dashboard a lot of information about the data that you're collecting. And we have also other products. For example, we have something we call a publisher, which allows to completely generate automatically content for your web from this, by basically grabbing the interesting stuff and pushing it directly to your website, etc., etc. But today I want to tell you a little bit about semantic analysis, which is Pau asked me to explain to you a little bit what's going on, but just to give you examples. I won't go in technically, but just give you examples of the kind of thing we do. It turns out there's two ways to do semantic analysis. One way, actually in linguistics in general, is two ways to go about computational linguistics. One way is to write your own rules. We didn't see the details in Review Pro, but I think this is the kind of thing they're doing. They're having dictionaries that says, look, these are the words we care about. These are the contexts in which we care about. And if you do this for a number of languages, you end up with rules, a rule-based system that can parse a small part of the human language. Because human language, unfortunately, it's all over the place. We tend to say things in many different ways, but nevertheless, you can do a lot with that. Another way to do this is based on machine learning, and as Pau said, I've been doing machine learning since 1994, when it was not only not trendy, but nobody knew what it was. And there was no hope to get a job at the time doing machine learning, of course. I was very lucky in that process. And what we do is actually very different. We don't build rules. We don't have dictionaries. What we have are human labelers. Students, very, very eager students, that spend their time telling the machine when it makes a mistake. So I will show you examples, but imagine that we're classifying sentiment, and the machine says, okay, this particular tweet is positive for Rajoy, and if it's a mistake, our human is going to say, no, it's not. Yes, it is. No, it's not. You made a mistake, right? It's correcting the computer all the time. And what we're doing is we're generating data, labeled data, we call it, because it's being labeled by a human. And then we have a machine learning process that basically looks at all of this data and tries to figure out automatically rules that somehow work to predict the data that it has, okay? Very much like a statistical model in that sense. And so the more data you have, the better these models get. but also the smarter you are about building the system, the better the systems get. And that's how we build these kind of loops, which allows us to learn semantics about hotels, about politics, about brands, about yogurts, about banks, without actually knowing much linguistics, but knowing enough to be able to map this process and get some good results. I'll show you some examples. So the point here is that we have a little artificial intelligence model that is actually making guesses all the time, and it makes a lot of mistakes, and the human corrects those mistakes, and over time this gets better and better. And the more the data remains stable, the better the system gets. But if we go from one domain to the next, for example, if I've learned a model that is very good at guessing sentiment of yogurts, and then I move over to the domain of credits or hipotecas, right? How do you call it? Mortgages. There's almost no relation between the two, and so the machine is going to make a lot of mistakes. But if the sentences become more and more similar to what it's seen before, it will be better and better. So in the case of hotels, for example, after you tell him about 100 times that a Wi-Fi was broken, it will eventually know different ways in which people complain about Wi-Fis, and so it will learn to tag automatically, right? I don't have time to go into details, but just you get the general idea. And this is what's called machine learning. And machine learning is trendy now because it's, for the first time since it was invented in the 1940s, it's actually working. It's actually generating very accurate results, better than those that are being generated by people who are building programs. So the latest few results, for example, the AlphaGo competition in which a computer beat the best Go player or the second best Go player in the world, when they beat Kasparov many years ago, they did it writing an actual program. When they beat the Go player now, they didn't actually write the Go program. They just let the machine learn to play Go. So it's a different approach to solving problems. Okay? And for those who are interested, they just beat one of the best poker players in the world, Carnegie Mellon University, and so that's very exciting too. Even computers are getting good at bluffing, which is something unexpected, right? So just very quickly, the kind of things we can do with this technology, for example, we can listen into, we do a lot of things with cities. The city of Barcelona was one of our earlier clients. We listen to anything that anybody says about Barcelona, and we try to classify it in real time. This is actually not Barcelona. This is a borough in London. And what we're doing in real time is every sentence that somebody mentions about this borough, we classify it in one of 100 classes roughly, which has to do with, is it about transportation, bus, boat, bike? Is it about culture? Is it about crime? Is it about sports? And so we can get sort of like the DNA or what's being said about a city at a given time in real time. And you can even separate and say, okay, what is the mayor saying? What is the city saying? And what are people saying? These are two different channels. What the city is trying to sell to you is sports. And what people are trying to talk in real time and more is about security. So you can, for the first time in history, pick up these kind of differences that before would require massive polls that were very expensive and very inaccurate, right? So this is one type of opportunity in which we're moving in, which is sort of analytics in real time. Another one is prediction. So for example, this is the city of Barcelona, and this is the distribution of crime conversation. So security-related conversation, accidents, crime, etc. And so you see on a typical day, at 2 a.m., there's very little conversation. At 4 p.m., there's much more conversation. This is your profile of a typical Barcelona day. And we can do this because we've automatically classified comments into threatening or security or not security related. And so now if you see that for a particular day, your volume gets too high at a given time, you know something is happening, right? So now you can do the usual predictive analytics that we all do with normal data, but you're doing it with textual data, with people's opinions, with people's thoughts. And that's very interesting. You can detect crisis on the spot. You can see words like Coca-Cola, they have a natural tendency to appear. And if they suddenly appear more than normal, then something is going on, right? And if they appear in a negative context, then you have a crisis. And so you can do this kind of analytics where the machine in real time is saying, hey, this word is appearing too much in this context. And then the human can check and say, oh yeah, it is a crisis, and then it labels it as a crisis, and then we track this crisis. That kind of thing out of text can be done now. One more, this is kind of fun. Because it's data and you can have APIs, now you can hook it up to whatever you want, right? And this is an example of a German guy that hooked a Philips light that can go from red to green, and he hooked it up to an API, a semantic analytics API, for a particular, this was for his event, for his workshop. So whenever it said something good about the workshop, it would go green. If somebody said something bad, it would go red. The point of this is that you're making sensors, our opinions become sensors now. The same way you can measure temperature or humidity, you can start measuring people's opinions and turn them into data, right? And that to me is just truly exciting. Okay, just one more, just to give you an example of, this is a video, and should, it was working a few minutes ago.
I made
so today we're
particles,
going to be looking at
and what I want to do now is go through
some of the motivations and the problems, why we wanted to do. I'm going to
go through that array, and what I'm going to do is, and I'm going to not go all the way to the end of it. What I want to do is I need to create, okay, so I need particle A is element I. So I want to get the first thing from the array, which is I, and it's with an array list, it's dot size. So I want to get particle I, and then I also want to get particle B to be the next one, I plus 1.
Okay, I can try to search for it. Però tens teclat aquí? Posa Websays, a veure. Yeah, the first one is fine. No, the last one in English, I think. Yeah, that one there.
This one?
Yeah. So this is an example of a system that has been completely automatically learned. So it has no rules, it has no dictionaries, but you have humans that are labeling it. And so somebody's typing here, oh, but we need to see the bottom, otherwise there's no point. Oh, there we go. So somebody's typing, and as it's typing, we're sending this to an API, and it's being classified in real time. And we're trying to find is there's about 150 different categories of things that can go wrong in a hotel, okay? And you can see that as you're typing, the computer is guessing what is this sentence about. And if you change the sentence, it would automatically change the classes. So location was great is a congratulation, but was far from the center. It's a other product issue. And it explains why. It's because location was far is the bit of the sentence that the computer has labeled as interesting to this class. And of course, there's so many different ways in which you can talk that if you had to write rules for this, it would take forever, and you have to redo it for every language. So the approach we do is we basically start dealing with data, have people label it in real time. We employ about 10, 15 people that are just labeling data all day. And we build the models as we go along. Okay? So as you add words in the middle, it doesn't break the system, so it learns that some nouns won't affect the actual phrase, that kind of thing. Because if you just actually write a rule, you would have to write thousands of rules for every particular sentence, right? Okay, I won't go more into this, but the actual video that I had in the presentation actually show you how we turn that into analytics. But this video is just about the sentences. So can we go back to the... Okay. And so to get a sense of how accurate these things are, because it's very easy to show you a demo and say, well, it kind of works because it works for my 5 sentences, right? To get a sense of accuracy, we are now getting to the point where they're almost as good as humans. So humans on this particular task, so hotel reviews, 150 different classes, things that can go wrong, like bathroom is dirty, Wi-Fi is broken, 150 things. In 6 different languages, humans tend to agree about 90% of the time. That means that 1 every 10, they disagree, because some classes are very hard to tell. Is it one problem or the other? Is it heating or air conditioning? Is it noise? If I say, I couldn't sleep because of air conditioning, is it the air conditioner that is broken, or is it because the hotel is noisy? So there's an inherent ambiguity here. And about 90% of it is the accuracy of humans. And we are now reaching, without huge investments, we are not Google spending millions of hours of labeling, just with a little bit of labeling for this particular client, just one client, we're getting on the order of 85% accuracy. on the order of 80% accuracy, which is not that far from 90% accuracy. There's many ways to measure accuracy. Those who know, you know how tricky this kind of exercise is. But you're not far from human accuracy, okay? You're getting closer and closer. And that is just a small company in Barcelona with little resources. Imagine you can do, as you increase the level of resources and data, right? And so it means that for the first time in history, we can start doing these things, even for relatively medium, small projects, something that before you could not do. Okay, so that's all of my time. I just wanted to show you that data, textual data is becoming real data. It can be mapped into analytics. And companies like Websays are creating the new generation of applications in which we take opinion, we take textual information, and we bring it into data analytics and business analytics. If you want to know more, please go to our websites, come to our office, ask Oscar and me, and we'll be happy to tell you more. Thank you.